Hi, so today we're going to be doing the problem with the two situations in which the charges are placed on the x and y axes, and they're all located at the same distance of 5.40 centimeters from the origin. For each situation, we're going to determine the magnitude of the net electric field at the origin. So we're going to be using this equation, E equals K, the absolute value of Q over R squared. And since we're looking at magnitude, we're going to be breaking Q down into the QX and QY values. So if we take a look at situation A, the x-axis, we're going to start with negative 3.0 microcoulombs minus, because we're going to the left, 2.0 microcoulombs. But since we want the absolute value, we're going to do, it would be negative 5, but we're just going to put 5.0 microcoulombs. And for the y-axis, we just have the 5.0 microcoulombs. Again, it's just 5 because we want the absolute value. And these are both going to be converted to coulombs. And 1 micro is equal to 1.0 times 10 to the negative 6 coulombs. So we're going to get 5.0 times 10 to the negative 6 and 5.0 times 10 to the negative 6. And then we're going to plug all of these numbers into our equation here. So we get 8.99 times 10 to the 9 newtons per meter squared, coulombs squared. This is going to be over our 0.054 meters squared. And this is going to get multiplied by the 5.0 times 10 to the negative 6 squared plus 5.0 times 10 to the negative 6 squared. And this is going to end up equaling and that's going to be our answer for part A. And part B, we're going to do it the same way with the x-axis. We have negative 1 microcoulomb minus 4.0. We're going to get negative 5, but with the absolute value, that's going to come out to 5.0 microcoulombs. And for here, we're going to have 1 minus 6, since we're going down. And that would again be negative 5, but we want the absolute value, so it's going to be 5. And we're going to do the same thing here. These are both going to end up being times 10 to the negative 6. And then we would plug these into this equation, and we end up actually getting the same answer because these are both the same. We're going to end up with that as well for part B. Thank you.